All right, this is 3.1 part 2, the discriminant and quadratic inequalities. So first thing here, we're going to define what is known as the discriminant. So if you think about your solutions to a quadratic equation when you're solving a quadratic. So negative b plus or minus square root b squared minus 4ac all over 2a. We're going to define this part right here to be known as delta, called the discriminant. So negative b plus or minus the square root of delta all over 2a. So delta is defined to be b squared minus 4ac. Now you know from your experience that when delta is a positive number, due to the plus or minus, we're going to have two solutions, also known as two real roots. When delta is exactly equal to 0, the plus or minus will not matter and we'll only have the one solution. We call that one repeated real root. I'll talk about the repeated part in just a minute. And if delta is less than 0, if that's a negative underneath the square root, then we're going to have no real solution. So let me show you, let's see if we, a couple of examples here where, how about, oops. Okay. Consider y is equal to x squared minus 4. In this case, the discriminant delta would be b squared, which is 0, minus 4 times a times c, which is equal to 16. That is a positive discriminant. That's going to be two real roots. So let me jump over here to Desmos, and we'll take a look at the graph of that. X squared minus 4, right? So you can see the two real roots. Roots are x-intercepts, solutions to the equation being equal to 0. All right. Now, compare that to the following equation, x minus 2 quantity squared. See that x minus, well, let's change the x value here so it's distinct. There we go. So you see that this only has one real root. And the reason it's called a repeated root is because x minus 3 squared is x minus 3 times x minus 3. So that factor appears twice. That's referred to as a repeated root. But you can see we only have one solution in that case. And going back over here now, if you consider y is equal to x minus 3 quantity squared, well, x minus 3 quantity squared in expanded form is x squared minus 6x plus 9. Let's calculate the delta in this case. B squared, which would be 36 minus 4 times a times c, that is equal to 0. Delta equal to 0, you have one repeated real root. And then finally, what if your delta is less than 0? So very easy demonstration there. Get rid of this one, get rid of this one. Let's change our first function into x squared plus 4. And you know that is the parabola that's been shifted up 4 units. You see it now, we have no real zeros here. We have no solution. So in discriminants, if you start with y is equal to x squared plus 4, then my delta is going to be b squared, which again is 0, minus 4 times a times c. Delta is negative 16. Negative discriminant, no real solution. All right, so pretty easy to determine what your value of delta is. So the way they're going to ask questions is occasionally put in unknown constants here and make you solve for them. So there's a quadratic. I want to find the values of the parameter p. Parameter is just another name for an unknown constant, such that 2x squared minus 3x plus p equals 0 has two real roots. Well, I know that the discriminant describes how many roots I'm going to have. So b squared minus 4ac in this case is going to be 9 minus 4 times 2 times p, which is 9 minus 8p. In order to have two real roots, I need my delta to be greater than 0. So I need 9 minus 8p to be greater than 0. So let's see, subtract 9 on both sides. Negative 8p has to be greater than negative 9. And then divide both sides by negative 8. P must be less than 9/8. Similar equation or question on 2. What values of r will make us so that we have no real roots? Well, no real roots, we need our delta to be less than 0. So I need delta, which in this case would be b squared minus 4 times a times c. I need that to be less than 0. So I need 9r squared minus 4 to be less than 0. 9r squared to be less than 4. R squared to be less than 4/9. Now we're a little bit tricky here because we're taking the square root with an inequality. So when I take the square root on both sides, I have to interpret the square root of r squared to be the absolute value of r, like so. And if I write that into inequality form, that's negative 2/3 less than r less than 2/3. So this would be the values of r that make my equation have no real roots. And then the last part of this, which is really the next little section, is solving quadratic inequalities. So just want to run through that. We've already spent time solving quadratic equations. So how do you deal with quadratic inequalities? All right. So what I'm going to want to do on this one is I'm going to want to attempt to factor this if I can. So let's see, is it factorable? 2x and x. Looks like minus 3 and plus 1, right? So 2x. Okay, stop doing that. Oh no. Sometimes my mouse just gets crazy. Stop it. All right, I think that works, right? So let's see, 2x times x is 2x squared minus 6x plus x minus 3. Yeah. And the reason I want to do that is because I'm looking for all of the zeros. So I've got my equation already with 0 on this side. If I didn't have the 0 on this side, I would manipulate it to get it there. And then what I want to do is I want to find the zeros of all these factors. So 2x plus 1 equal to 0 implies x is negative 1/2. And x minus 3 equal to 0 implies x is 3. And then I'm going to do a number line, and I'm going to look at intervals. Now, if you can't factor it, then what you want to do is solve your quadratic equation equal to 0, either by completing the square or using the quadratic formula, and then you'll get the same zeros and you'll be able to plot them on the number line just like I did here. And I'm just going to do sign tests. I'm going to choose a number greater than 3. I'm going to substitute it into this factored form right here and see what I get. And I think it's pretty obvious if you choose a number like 4, it's going to work out to be positive, right? This will be positive and this will be positive. Choose a number between negative 1/2 and 3. How about 0? Positive and negative, that will result in a negative. And then go less than negative 1/2, like say negative 1. Negative and negative together will make a positive. And now I'm just going to look to see what, so my inequality here is greater than or equal to 0. So I'll be greater than or equal to 0 here and here. So my solution then is going to be x in the interval from negative infinity up to negative 1/2 and 3 to infinity. And now the question of, do I include? You never include infinities. I'm going to include the endpoints here because I want greater than or equal to 0. And I know this function is actually 0 in those places. If I only had the strictly greater than, I would not include, but in this case, I'm going to include.